Welcome. In this problem, we are going to solve an honors physics problem regarding Newton's second law of motion. And you can see from this problem, we have a 10 kilogram box, and we're acting on it from two directions. The direction on the left, we have an 8 Newton force with a 30-degree angle from the horizontal. And on the right, we have an 8 Newton force that's 80 degrees from the horizontal. And just by looking at this, you can kind of guess that it's probably going to end up moving somewhere out in this direction when these two forces get combined. But we're going to actually do the math, and we're going to show this. And we can't just simply add these 8 Newton forces together or subtract them because the angles are different. So what we're going to have to do is we're going to have to break these apart into x parts and y parts. So we're going to start by making a little graph over here. We have our x part, and we're going to have our y part. And we're going to draw these two vectors, these two forces. So the first one comes in over here, and it's making a 30-degree angle. And the second one is this 80, and it kind of looks like this. It is making an 80-degree angle, and it's also 8 newtons. So what we want to find is we want to find basically this x part and this y part, and this x part and this y part. So we have a triangle happening here. And so we can use our trig functions, sine and cosine, and we could say for the x part that cosine of 30 degrees, our angle, is equal to the adjacent over the hypotenuse. So the adjacent to the 30-degree angle is our x, and our hypotenuse, because the right triangle's over here, the hypotenuse is 8. And in order to solve this, we multiply both sides times 8. And so we basically get 8 equals 8 cosine 30. So x equals 6.93. We'll take this out to just 2 decimal places. So I'm going to do the same thing over here for the y. For the y, except this time we're going to use sine. So we have our sine of our angle. This time it is equal to opposite over hypotenuse, and our opposite of the angle is the y, and our hypotenuse is still 8. So doing it the same way, we multiply both by 8, and we get y equals 8 sine 30. And putting that in a calculator, we get 4. We're going to do the same thing for the second vector, the second force. I'm going to write it a little bit briefly. I'm going to skip some steps. I'm going to say x equals 8 cosine 80. So I'm just skipping the fraction form and multiplying it right away. And 8 cosine 80 equals 1.39. And the y part will be y equals 8 sine 80. And so throwing that in my calculator, I get 7.88. All right, the next thing I need to think about are the signs. Because you can see these are going in different directions, these two forces. And if we think about our normal Cartesian plane, anything going up is positive, anything going down is negative. Anything going to the right is positive. Anything going to the left is negative. So when I look at my first force vector, it is going to the right. So the x portion is positive, which is what I have. And it is going up. So my y portion is also positive because it's going up in the positive y direction. My second vector, though, it starts way up here, and it's going down and to the left. So because it's going left, the x part is negative. And because it's going down The y part is negative. So now what I have is I have these two forces, and I have them broken up into x parts and y parts, and so now I can add together the x's and the y's. So we're going to do that. So my x is 6.93 minus 1.39 because of the minus. And my y part, I'm going to add my y's together. I have 4 minus 7.88. I'm going to put those into the calculator. I get 5.54 and negative 3.88. So what I just solved was the x portion and the y portion of my answer. So if I go back to my box over here, the x portion of the answer is 5.54. So it is 5.54 this way, and the y part is down 3.88 because it's negative. It's not quite drawn to scale, but that is the x portion of my answer and the y portion of my answer, and the answer I want is going to be this hypotenuse. So to find this hypotenuse, I have the x and the y, so I am simply going to use the Pythagorean theorem. So my final force is going to be equal to the square root of a squared plus b squared. That's my final force. It's going to be equal to square root of 5.54 squared plus negative 3.88 squared. So my final force is 6.76 newtons. So that is the final force by adding those together. I may also want to find the angle. So to find the angle that this is happening, my angle right here, and I did just find that this side was 6.76. But I want to find this angle. So to find this angle, I'm going to use a trig function. Again, I'm going to use tangent. And I'm going to say that my angle is equal to inverse tangent of opposite over adjacent. And my opposite is my y. My adjacent is my x. So my angle is going to be equal to the inverse tangent of y, negative 3.88, over my x, which was 5.44. And I put that into the calculator. To get an angle of 35, actually negative 35.5 degrees. And finally, I'm going to finally get to what the question was asking. The question was asking for what is the acceleration. And I now have a force. My force is right here. And I had a mass, the mass of the box. The mass of the box is right here. So if I have a force of 6.76 and a mass of 10 kilograms, and I want to find the acceleration of this box. So I'm going to use F equals ma. 6.76 equals 10a. Divide both sides by 10. And my final answer will be A equals 0.676 meters per second squared. So to quickly recap, when I start off, I break things down into my components, my x components and my y components, and I do that for both of them. I then make sure the signs are correct. If it's going to the right, it is positive in the x direction. If it's going to the left, it is negative in the x direction. And if it's going up, it's positive in the y direction. Down is negative in the y direction. Made sure my signs were correct. Then I added them together in this step right here. After I got those, I recombined them using the Pythagorean theorem to find the total force. I then found the angle using tangent. And then I came back over here to the left and I found the acceleration using Newton's second law.